The key to applying integration by parts then is to choose an integral that's the most complicated that I can integrate. Now, with the log functions, what we want to do, if we have a power on the x inside the log, really we should bring that out as a coefficient. Okay, that just makes things so much easier whenever we do that. So I'm going to first do that. So I'm going to now integrate this. I can't integrate x log x. The key again was I need to choose a dv part, which I'm going to integrate, but it needs to be the most difficult part of this that I can integrate. So I know I can integrate x. So I'm going to put x dx. I'm going to integrate that. So what's left over then is my u is going to be log x. Okay, so I've chosen my dv, the most difficult part that I can integrate, and u is the other part remaining. I'm going to generate a du part for my formula. That's going to give me 1 over x times dx. I'm going to integrate the dv to get my v for my formula. So I'm going to end up with x squared over 2. Okay, so once I've done that, I'm going to apply my formula. So this expression, I'm just going to generate an equivalent integral that hopefully is easier. So this looks like this. This is an equivalent. So I'm going to do u times v. So u times v is log x times v, which is x squared over 2. Okay, and oops, I need to make sure I have my 3 in there. Don't forget that 3. So this is equal to 3 times. Okay, so there's my u and v. So there's my v is going to be this part here, and my u is this part here. Okay, I've kind of switched it around, but it just makes it easier to look at when I do that. Minus, and this is the important part here, I need to evaluate to see if this new integral, which is v du, so v is x squared over 2, and times du is going to be 1 over x dx. Does this new expression integrate more easily than the first one? And the answer is yes, because that's just going to simplify to an x function. Okay, so I'm going to factor out the 2 out of here. So this is equivalent to 3 over 2. And then I end up with x squared log x on the outside of the integral. This simplifies into the integral of x dx. Okay, so then just so that you guys can see this, that 2 in both cases came out on the outside out here. If you're wondering where that 2 went, divide by 2. So I just put it on the outside. It's easier for me to integrate when I don't have to worry about those parts. So then the answer is going to be x squared log x minus x squared over 2, and don't forget the plus c. Okay, so there's my integration by parts.